Hi students, this is P. Eswari, working as Assistant Professor of Mathematics in Vignan Institute of Engineering for Women. Today I would like to give a lecture on linear differential equations of first order. Before going into the topic, first let us know what is a differential equation. A differential equation is an equation which contains the derivatives, or a differential equation is an equation which contains the derivatives of dependent variable with respect to one or more independent variables. So next we will go into the topic of linear differential equations. So this linear differential equations of first order has two forms. That is, the form 1 is linear differential equation of first order in y, and the form 2 is linear differential equation of first order in x. The form 1, the general form of linear differential equation of first order in y is dy by dx plus py is equal to q. Let me explain with an example. Dy by dx plus 2xy is equal to 3x square. Now observe this differential equation. Here y is the dependent variable and x is the independent variable, right? The dependent variable y and its derivative dy by dx both appears in the first degree only, right? Y and dy by dx both appears in the first degree only. So this is called a linear differential equation of first order in y. Next, observe again, the multiple of y is here 2x, which is a function of x, and the right hand side part is 3x square, that is also a function of x. So here an equation of the form dy by dx plus py is equal to q, where p and q both are functions of x or constants only, then this is called a linear differential equation of first order in y. So the second example is dy by dx plus 2y is equal to 3. Observe, this is also a linear differential equation of first order in y, because here y is of order 1, degree 1, and dy by dx is also of degree 1. Both are degree 1, and the multiple of y is here 2, p, which is a constant, and the right hand side part is 3, q is equal to 3, which is also a constant. So the general form of linear differential equation of first order is dy by dx plus py is equal to q, where p and q both are functions of x or p and q either a constant. So here we have some working procedure to solve the linear differential equation of first order in y. Here first we need to find the integrating factor, which is e power integral p dx, and the general solution of this linear differential equation is y into integrating factor integral q into integrating factor into dx plus c. Let us have a better understanding with an example problem. So this is the first example. Solve x plus 1 into dy by dx minus y is equal to e power 3x into x plus 1. First we have to identify whether it is a linear differential equation or not. For that we have to concentrate on the dependent variable y. First observe in the question, here y is of degree 1 and dy by dx is also of degree 1. So this is a linear differential equation of first order in y. First we have to convert this question into the general form. What is the general form of linear differential equation of first order in y? Dy by dx plus p of x into y is equal to q of x. So we need to convert the given question into this form. For that there should be no term before dy by dx, but in the question we observe that x plus 1 is a term before dy by dx. So to get the general form, we have to divide the entire equation with x plus 1. So after dividing this equation with x plus 1, we get dy by dx minus 1 by x plus 1 into y is equal to e power 3x into x plus 1 by x plus 1. So which is a general form. Now observe this question, x plus 1 into dy by dx minus y is equal to e power 3x into x plus 1. After dividing with x plus 1, we have dy by dx minus 1 by x plus 1 into y is equal to e power 3x into x plus 1 by x plus 1. There is a small correction here, we have x plus 1 whole square. So x plus 1 whole square by x plus 1. So after comparing this, we have p is equal to minus 1 by x plus 1 and q is equal to e power 3x into, after x plus 1 and x plus 1 cancel, we have q is equal to e power 3x into x plus 1. Now let us going into the working procedure. First we have to find the integrating factor. The integrating factor formula is e power integral p dx. So integrating factor is e power integral p dx. What is p here? Minus 1 by x plus 1 into dx. That is e power minus, what is integral 1 by x plus 1? Log x plus 1, which is e power log x plus 1 whole to the power of minus 1. Which is, when in e and log will cancel, we have x plus 1 to the power of minus 1, which is 1 by x plus 1. That is our integrating factor, 1 by x plus 1. Now, let us now find the general solution. The general solution of this is y into integrating factor equal to integral q integrating factor into dx plus c. So that is y into, we already have the integrating factor 1 by x plus 1. So 1 by x plus 1 is equal to integral q. What is our q? E power 3x into x plus 1 into, our integrating factor is 1 by x plus 1 into dx plus c. When x plus 1 cancel, we have integral e power 3x into dx plus c. What is integral e power ax formula? E power ax by a. So integral e power 3x is e power 3x by 3 plus c. So the left hand side part is y into 1 by x plus 1. So after multiplying with x plus 1, we have y is equal to e power 3x by 3 plus c into x plus 1, which is the solution of the given differential equation in y. Next, let us discuss the second example problem. So which is, solve dy by dx plus y by x log x is equal to sin 2x by log x. The question is already in the form of linear differential equation in y, because y is the dependent variable, appears in the first degree, and dy by dx is also appears in the first degree. So this is, we can easily tell this is a linear differential equation of first order in y. Now compare with the general form, dy by dx plus p of x into y is equal to q of x. After comparing, we have p is equal to 1 by x log x and q is equal to the right hand side part, sin 2x by log x. Next, we need to find the integrating factor. Integrating factor is e power integral p dx, which is e power integral. What is our p? Our p is 1 by x log x dx. So, we have to find the integration for integral 1 by e power integral 1 by x log x dx. So, we don't have a direct integration for this. For that, we have to take this log x as t. Let log x equal to t. When log x equal to t, what happens? 1 by x into dx is equal to dt when we are differentiating this with respect to x. Now, substitute here e power integral, what is 1 by log x. What is our log x? Log x is equal to t. And 1 by x dx is nothing but, 1 by x dx is nothing but dt. So, e power, what is integral 1 by t? Log t. So, which is nothing but e power log. What is the value of t? We assumed it as log x. So, t is equal to log x. So, e power log of log x. When e and log cancel, we have log x. So, which is nothing but our integrating factor. Next, Coming to the general solution. So the general solution is y into integrating factor integral q into integrating factor into dx plus c. So y into what is our integrating factor? Integrating factor is log x. So log x is equal to integral q. What is our q of x? Sin 2x by log x. Sin 2x by log x, and our integrating factor is log x into dx plus c. When log x and log x cancel, we have integral sin 2x dx. What is the formula for integral sin 2x dx? Integral sin x formula is minus cos x. So integral sin 2x formula is minus cos 2x by 2. So integral sin 2x, when log x and log x cancel, we have integral sin 2x. The integration of sin 2x is minus cos 2x by 2 plus c. So this is our solution. After dividing with log x, we have y is equal to minus cos 2x by 2 into log x plus c by log x, which is our solution. Next. So that is for linear differential equation of first order in y. So far we have discussed. Now let us going into the form 2, which is a linear differential equation of first order in x. So for that, consider when linear differential equation of first order in y means the dependent variable y and its derivative dy by dx both appears in the first degree. For linear differential equation of first order in x, the dependent variable x and its derivative dx by dy both should be appears in the first degree. So here if you observe, the power of x is 1 and also dx by dy degree is 1. So this is nothing but a linear differential equation of first order in x. Let me explain with an example. So consider dx by dy plus 2y into x is equal to 3y square. So this is a linear differential equation of first order in x. Why? Because the power of x is 1 and dx by dy is also appears with a degree 1. So this is a linear differential equation of first order in x. And observe here, the x multiple is a function of y, p of y, and the right hand side part is 3y square. This is also a function of y. So p and q both are functions of y, or they can be constants. For example, the equation can be like this. So 2x is equal to 3. If we observe, this is p and this is q. Both p and q either a function of y or p and q can be a constants. Thus, this is the linear differential equation of first order in x. For this, we have to solve the equation like this. The integrating factor is e power integral p dy, and the general solution is x into integrating factor integral q into integrating factor dy plus c. Now we will have the better understanding with an example. So this is the first example. Solve x plus 2y cube dy by dx is equal to y. First we have to observe whether the given equation comes under linear in y or linear in x. For that we have to concentrate on the variables. If we observe here, x is a variable appears only once with a degree 1. So this is a linear differential equation in x but not in y, because y and y cube appears 2 times with degree 3. So this is a linear differential equation in x. For linear differential equation in x, the general form is dx by dy plus px is equal to q. First we have to convert the given question into this form. For that we have to do x plus 2y cube dy by dx is equal to y. First let us write what is dy by dx. dy by dx equal to y by x plus 2y cube. Then we have to write in the form dx by dy. For that we have to reverse the fraction. So dx by dy is equal to x plus 2y cube by y when reversing the fraction. Then separate the terms here. X by y plus 2y cube by y is nothing but 2y square. The left hand side is dx by dy. So dx by dy, when it comes to the left hand side part, minus x by y is equal to 2y square. Now if we observe this equation, this is a linear differential equation in x. So dx by dy plus p of y. P of y is nothing but minus 1 by y into x is equal to q of y, which is 2y square. So p is minus 1 by y, q is 2y square. Next, integrating factor. Integrating factor is e power integral p dy. This is the first step of our solution. So e power integral, what is p? After comparing, we get p is equal to minus 1 by y. Minus 1 by y dy, which is e power minus, what is integral 1 by y? Log y. So e power log y power minus 1. When e and log cancel, we have y power minus 1, which is 1 by y. So the integrating factor is 1 by y. Next, the general solution formula. This is the general solution formula: x into integrating factor, integral q into integrating factor into dy plus c. So x into, what is our integrating factor in the before step? It is 1 by y, which is 1 by y. Integral q. Q is 2y square, that is our right hand side part, 2y square, and our integrating factor is 1 by y into dy plus c. When y and y cancel, we have integral 2 into dy plus c. So 2, when y and y cancel, we have integral 2y dy plus c. 2 into, what is integral y power 1? Y square by 2. When 2 and 2 cancel, we have y square plus c. This is our general solution. So x into 1 by y is equal to y square plus c. Then x becomes, when multiplying with y, it becomes y into y square y cube plus c into y cy. So this is our first example. Next, let us go into the next example. Solve 1 plus y square plus x minus e power tan inverse y into dy by dx is equal to 0. First, we have to identify whether it comes under linear in y or linear in x. For that, we have to observe the variables. If we observe the variable x appears with a degree 1, but the variable y appears with a degree 2. So this is a linear differential equation in x. For that, we have to convert it into the general form: dx by dy plus px is equal to q. For that, we have to first find what is dx by dy. First, let us write the equation as x minus e power tan inverse y into dy by dx is equal to, let us take this 1 plus y square to the right hand side part, which is minus of 1 plus y square. Then dy by dx become minus of 1 plus y square divided by x minus e power tan inverse y. Now we have to bring this into this general form dx by dy. Further, reverse the fraction. Dx by dy becomes x minus e power tan inverse y by minus 1 plus y square. Now separate the terms here. Minus x by 1 plus y square, minus by minus is plus, e power tan inverse y by 1 plus y square, which is dx by dy. So dx by dy, bring it to the LHS part, plus x by 1 plus y square is equal to e power tan inverse y by 1 plus y square. So this is the general form of this first order linear differential equation in x. Dx by dy plus p of y. Observe here, p of y, function of y is 1 by 1 plus y square, which is p, and the right hand side part is e power tan inverse y by 1 plus y square, which is q. Next, integrating factor. So the integrating factor is e power integral p dy, which is e power integral p. What is our p? Our p is 1 by 1 plus y square dy. We know that integral 1 by 1 plus x square dx is tan inverse x, right? So e power integral 1 by 1 plus y square dy is tan inverse y. This is our integrating factor. Next, the general solution is x into integrating factor, integral q into integrating factor into dy plus c. This is the general solution. X into integrating factor is e power tan inverse y is equal to integral q. Our q is e power tan inverse y by 1 plus y square into our integrating factor is e power tan inverse y into dy plus c. Next, so we have to solve this integration. For that, we have to take tan inverse y as t. When tan inverse y is t, derivative of tan inverse y is 1 by 1 plus y square dy is equal to dt. Then it becomes, look at this, it becomes e power, what is tan inverse y? Tan inverse y is t. Next, 1 by 1 plus y square into e power, again tan inverse y is t. 1 by 1 plus y square dy is nothing but dt. that is integral e power 2t into dt. What is e power integral 2t? Which is e power 2t divided by 2. That is e power 2 into t. T is nothing but tan inverse y. Tan inverse y by 2 plus c. Observe the right hand side part, e power 2 tan inverse y by 2 plus c. So this is the solution. After dividing with e power tan inverse y, we get x into e power tan inverse y is equal to e power 2 into tan inverse y by 2 plus c. So this is the linear differential equation of first order in x. This linear differential equations has a wide range of applications in engineering. So these are used to find the motion of a body and also used to find the current and charge in an electrical circuits. Next we have a topic Bernoulli's differential equations, which can be discussed in the next lecture. Thank you students.